our first Python code jam session. And as Dilek mentioned, we're going to be having it every other week. So we're pretty excited about it. So basically, this is the session in which we're going to elevate your Python skills through live coding sessions. So yeah, we're going to be coding live. Okay, so a little bit about the dynamic. So we're gonna be solving 3 problems from the Python challenges. So you know that we had the 100 day of code challenge, in which every day we share a challenge so everyone could solve it. And so we are picking the ones that the people suggested the more suggesting them more to code them. So yeah, and today is gonna be the first 3 problems. You can code along with me. So you can use, like, if you're using a Python notebook, if you're like Jupyter notebook, your lab, or like your preferred code editor, we can do it together. So yeah. I'm gonna be presenting different approaches on how to solve them, each of them. And well, I'm gonna be coding here, but if you have any questions through a chat, maybe Dilek can share the questions with me and we can chat about it and whatever. And yeah, and I'm gonna be responding to every question that you have. So yeah, so we're gonna be like this little kitty, and it's gonna be so much fun. So okay, let's start. So first, I want to give a quick introduction of Big O notation. I want to mention this because we are gonna be exploring the Big O notation of each of the approaches that we're using. So if you're not familiar with Big O notation, basically with this, we are expressing the algorithm complexity using algebraic terms. Usually these are expressed using functions, like mathematical functions. So we have constant, which is of 1, of log n, which is also an of function, of n, which is like linear, of n to the 2, I don't know how to say, but it's like quadratic. So in here, you could see like how it's gonna be changing based on the function that we're using, right? So we have n, it's gonna be the input. So for example, in here, if it's of 1, it's gonna be constant time. So it's not gonna be affected because the input is constant, right? But for example, in here, when we have an input size of n and we are having like log of n, it's gonna be like increasing following the function of log of n, right? Logarithmic function. As well, we have the linear function, and as well we have the quadratic one. So basically, we can use it for to express time complexity and space complexity. So times complexity refers to how much time it's gonna be an algorithm takes to run. So as you can see, well, it could depend, but what we want to try when we're like a little bit more advanced, we are trying to go to the lowest to be the most performant. And when it comes to space complexity, what it means is that how much memory is going to be used by a specific algorithm. So when we have variables or lists or anything, that's going to be adding up to your space complexity. So yeah, this is just a quick overview. We're not gonna go that in depth. We just want to solve the problems, but I wanted to share this so you can take it into consideration in the future, right? Okay. So today I'm gonna be using a combination to show you how it works from a collab notebook. So it's gonna be like any other notebook, and also from VS Code. So the first two problems I'm gonna be solving them through collab, and the last one I'm gonna be solving it through VS Code. Okay, so the first one is find the sum of all elements in a list. Sorry. Oh, sorry. So we're gonna go um to this notebook that I already created. If you see it, I don't have anything, so we're gonna be coding live. um but yeah, basically I think after the session we could share like a compiled version of the all the approaches that we touch, so you're able to get it on your own, and you can also, as I told you in the beginning, you could also go with me, right? Okay, so let's start with the first approach. Okay, so I'm gonna be creating a function, and I'm gonna be calling it sum list, right? So basically, what it says here is to find the sum of all elements in a list. So the function, it's gonna have as an argument the list that we are gonna be summing, right? Okay, so we could do it easily. Basically, we could just use the already existing uh, method or function sum, and this will be good to go, right? This will be like the simplest way to do it. So basically, what to call it, we just like add the function, and then we could add any like numbers.
Nydia, sorry. Someone asked if you could zoom in a little bit.
Oh, okay. Yeah.
Thank you.
Yeah, no problem. Let me see if I do this. Is it better? No, yes.
I think, yeah, they say better. Yeah, thank you.
No problem. Okay, so basically we're gonna be including any numbers here. But yeah, that's a tricky thing, because this approach, if I run it, let's say, so it's gonna give me the number 3. But if you see, this one is the simplest. I mean, we are not even saying, oh, so the sum of these elements is this, or something like that. So it could be a little bit, we could improve it, right? But this one works. But what happens if we enter a character? We are not validating those scenarios, right? So yeah, that's something that we could improve, right? So okay, so the approach number 2, it's gonna be a little bit more pumped. So yeah, we can call it the same. And we're also gonna be receiving a list, and we could do it instead of doing it for using the already existing methods sum. We could like iterating, right, through the whole list. So what we can do is that we can create a variable. Oh, sorry, I forgot to. Oh, we can do it in the end to share the time and space complexity. Okay, so what we can do is like we could iterate over all the elements in the list, and then we could add the element, right? And then in the end, we can return. And what we can do is like we could do it a little bit more pretty, like so the sum, the sum is, and then we have sum, right? So, okay, and this should work, I guess. Oh, but I didn't call it. So we could reuse the same list that we have. Please let me know if I'm going too fast or something, and I can like do it slower or something. Okay, so this one we handle to be a little bit more like user friendly, because in this one we just like, okay, this here's the number. But in here we have it like, okay, so the sum of elements in the list, we could say, is this. And yeah, okay, but we are still not facing the issue that we have if we enter a character, right? So that's gonna be the third approach, because usually when we are like trying to create some functions, we can do in the simpler way, but we can make it more robust, so we can handle specific exceptions that might happen. So for example, this could be like, okay, so someone is gonna play and like add a character or add an object or something. So yeah, we want to take those scenarios into consideration, so we avoid like possible bugs or something. Okay. So okay, so the third approach, it's gonna be handling um the type of the element in the list, right? So it was still receiving an element as an argument. We're gonna be using reusing the same sum, like to go iterate by element. So what we could do, it's like for element in list, there is a function called isInstance. So basically, isInstance, what it does is that it evaluates element, the whatever that you're trying. In this case, we're trying to evaluate the element against a specific type. In this case, we want it to be integer, right? But what we want to handle, it's to avoid summing the element that is not an integer, right? So what we could do is like, if not, meaning that if it's an element that is not an instance of this specific type, in this case it's an integer, what we could do is like, we could let the user know that that specific element is not an integer, right? We can just let them know here, and maybe we can break the whole procedure, or we can continue to the next one. So we could say, so this element is not an integer and cannot be summed. Okay, and we could use the keyword continue. So the keyword continue, what it's gonna do is like, it's gonna so for this specific iteration, it's gonna skip the next part of for example, if I had something else here, so here, for example, it's gonna be skipping from this point. So we could either continue is gonna go to the next iteration, and break, what we'll do is like break the whole like loop, but we want to continue, right? So in here, after doing this, we can do it as normal, which was the one that we have before. Yes. And then in here, we can return the sum. Or we can return this, right? Like that we have it like this prettier. Mhm.
Nydia, someone asked if you were able to talk about the time and space complexity for all approaches.
Yeah, I'm gonna I mentioned at the beginning that I forgot to mention it here, but I'm gonna mention it in the end. For this problem, I'm gonna mention each of the approaches. Okay, so then and here we can evaluate the other scenarios. First, let's see if it works, right? Like if it works for all the like the one that we have. Yeah, so it's working. But now we wanna try to see if it's gonna avoid us that type error. Yeah, so right now it's telling us that that this specific element is not an integer. In this case, like is a character and cannot be included in the sum, right? And we could also do it with an object. Yeah. So yeah, I think this is the approach that could handle those specific scenarios. And I think it's looking it's giving all the information to the person that wants to use this specific function. And we could also do it like input. For example, if someone wants to enter their specific list, we could also do it like that. I'm going to explain an example of that through the VS Code. So yeah. Okay, so let's go to time and space complexity, right? Okay, so as I mentioned, we use O notation to do it. Okay, so how we evaluate the time complexity? So the time complexity is first we need to verify what are we entering in our algorithm. In this case, we are using an existing function from Python, which is the sum, but we are entering a list, right? And a list can be of n elements. So it could be we just have 5, but it could be 1,000, it could be 1,000,000, it could be I don't know. And so the time complexity here, if we had like a constant input, it will be of 1. But in this case, because we are going through and how it works, this method or this function, it's like to go through all the elements of the list, then the time complexity of this one is of n. Okay. And then the space complexity, it's gonna take into account if we have any additional variables or if we are saving any specific amount of data. But in this case, since we are not using any additional variables, for example, if we had to use another list to store something, then we know that we have n elements in that list, then the space complexity will be of n, sorry. But in this case, we are not, so it's gonna be of 1. Okay. Then, okay, so this is this one, right? This is the approach number 1, the approach number 2. Well, I'm not gonna erase it, but it's gonna be similar. In this case, as I mentioned, we have a list with n elements, and n could increase up to I don't know, a million or whatever. And we are iterating through all the elements in the list in the for. So basically we have, based on that, based on the iteration, we are having a time complexity of n. And when it comes to space complexity, we are not using any additional space, or we don't have any other list where we're saving something. And even though we are using this variable is going to be a constant. It's not going to have n elements. It's going to be either of, let's say, in this case, it's going to be 3, right? So it's going to be of 3 if we would. But that's like translated to of 1. Because it's going to be any value, any constant value here. So yeah, it's going to be of 1. Also, I think in below we're gonna have an example where we're gonna sum some complexities. But how we get the time complexity or the space complexity of big O notation, we just want to take. We don't care about the constants. So if we have 2 of n to n, sorry, for example, in the end it's gonna be n of n. Okay, and this one, it's similar. We in here we are just using this, but basically it's only comparing an element to it's gonna be just one element through a specific data type, and it's gonna be similar. We're gonna be iterating through all the elements of the list. So since we have a list and could be of n numbers, then it's gonna be the same. I don't know if anyone has any questions up to the moment, or we can
So far,
continue.
yeah, we didn't have any questions, but let's see.
Okay, good. Okay, so now we're gonna go to this one. Right. So okay.
Oh, Nydia, before you go ahead, is someone asked when there is an iteration of there's an iteration, is it 2n?
Whereas one iteration, it's gonna be of n. When you have 2 iterations, I mean, nested loop, let's say, is gonna be of n to the 2 or to the second. This one, sorry, I don't know how to pronounce it, but it's like of n. Where is the little thingy? I don't see my, but it's of n to the quadratic, right? When we have two nested loops. So if in here I had another 4, that one it's gonna be iterating through this. Okay, it's gonna be iterating through all the elements of the list, and then it's gonna be iterated in this iteration for all elements of that list. So usually when you have nested loops, you're gonna have a quadratic, and if you have like 3 loops nested, is gonna be a third to the third, I don't know, power. So yeah, we should avoid nested loops.
Nydia, is it possible to show the complexity with other functions? Someone asked, like log of n or
Yeah,
n
I'm gonna be
squared.
showing log of n, n log of n, which is sorting. Larry is saying is iteration of the loop is +1. But yeah, but that you're assuming that it's only be having 10 times, but it's not constant because it could be n, it could be 100, it could be a million, it could be a billion. So we are gonna have of n, so it's not constant. Yeah. Okay. Yeah, I'm gonna show n log of n. for sorting. Yeah, but I'm going ahead. So yeah, yeah, I can show as well. Okay, so let's see. So we're gonna write a program to find the maximum and minimum values in a list. Yeah, exactly. The after array is variable. So we usually the big of notation we try to consider the worst case scenario. So we need to consider, okay, so how larger could this list be? And it's gonna be n. So yeah, that's why we say of n. Yeah, exactly, Laurie. We say the same. Okay, let's continue. Okay, so in here we are I'm going to find the max and minimum values in a specific list. So we could create a function. Let's go max and min. Oh, sorry. Of a list, right? Okay, so as I mentioned before, the easier way would be, right, to use the existing functions, right? So it would be like to get the min of the specific list or get the max or the specific list. And then we can return a tuple with the two values, right? Okay. And in here, we use this same array, not this one. And we could find marks. Of this list. Sorry, sometimes I interchange array and list, but we know that it's the same. Okay, so yeah, and if we run it, it's gonna give me the min and max values of that specific list, right? So in here, if you can see, this one is interesting. This one, it has the same case as I told you, that we're gonna have 2n. So why? Because this one, okay, let me just write down. Okay, so we have the min function, right? The min function is gonna iterate through all the elements in the list. So it's gonna be n. And the max function is gonna be also iterating through all the elements of the list. It's gonna be n. So we're gonna have 2n, right? So if we sum, but that could be reduced. As I told you, the constant values are not important. So in the end, it's gonna be of n, right? And for space complexity, we are gonna be half of 1. Since we don't have any additional space using either like just constant values, right? But we don't have any list or something in which we are storing information. Okay, so let's go to the well, this one we could also write it down like prettier, like the mean value is this and the max value is that. Yeah, I mean that would depend on how you decide to do it. Okay, so this one's gonna be a simpler way, as we already are using like the min and max, the existing functions for that. But we could do this one is the approach that I was telling you, that it could be more interesting in a way. So what we could do is that, okay, we have this list. This list is not sorted, right? What we could do is that we could sort the list. I'm sorry. And then we're gonna return the first element of that list, of the sorted list, and the last one. And then if we use the same, it's gonna give me the same values, but this one is tricky. Okay, so this one, maybe you could see, oh, this is more readable. It's only one line of code or something. So it's just, you have just this one, right? But that's like a trade-off, because this one, it's having a complexity of n log of n. Why? Okay, this is because of how the sort function works. And basically all the sorting algorithms start with the n log of n. For example, if you the simplest sorting algorithm is the binary search. And what we do in that one is like divide and conquer, right? So what do I mean by divide and conquer? We need to yeah. Yeah, understand. Oh, okay. We are responding to someone. Sorry. Okay, sorry. So divide and conquer is approach in which, as it mentions, you're gonna divide whatever that you're trying to sort into different elements, and then try to go to the smallest scenario, let's say, and then you're gonna in that division that you're doing it through all the elements of the list. So n it's gonna be the elements of the list, and log of n is gonna be represented by that divide and conquer part. So almost all sorting algorithms use, or are, this is the like the best scenario, but they could be even worse in performance. uh as I well, I think I don't have the the graphic. But yeah, it could be a little bit like right here, maybe like a little bit above because it's n. So yeah, it's not, sorry, it's a little bit above here. Sorry. So we want to avoid it, not avoid it, but what we want to do, as I mentioned, is try to use the smallest. But that's like the trade-off. If you want, for example, to be more readable, to do it in one step or whatever, then okay, you decide, oh, okay, I'm gonna be using this. But if not, then you can use this approach. So yeah, that would depend on you and how performant you want like your code to be. And the space complexity is also going to be of 1, because we are not using any additional space. For example, if this function didn't allow to have it in place, and we needed to use an additional list, then it's going to be of n. But in this case, it's of 1 because we are doing an in place sorting. Right? Okay. And the last one, the last one is like like doing this but with less than and greater than. So okay, so in this one, um, oh, sorry. Okay, so what we do is that we initialize the values to the first element of the list. So we have two variables, min value and max value. And what we're gonna do is that we're gonna be iterating through all the elements of the list. And we're gonna compare, right? So it's like doing this min and max like step by step or from scratch. So we're gonna be comparing.
Nydia, someone asked if you could share slides. You showed a few seconds ago.
This one?
Yes.
Yes. Do you mean like share the whole slides? Like share the link?
I'm not sure. Nisrin, do you need to see it now, or you want to you want us to share? I think we will be sharing the slides, right?
Yeah, we'll be
After
sharing.
the session. Yeah, you can check our Slack channel for the updates.
Okay, he just said share the links of the slides. Do you think we could share?
After the session, right? We can do that.
Okay. Yeah. Maybe you can take like if you want this part, you can take a screenshot, right? And you have it on your records or something. We will share it afterwards, yeah. Okay, so okay. So it's gonna be okay, so if the element is less than the minimum value that we already have, then the minimum value is gonna be the new element. And since we need to do the two at the same time, so we also evaluate the max value, right? So it's gonna be if the current element that I'm evaluating it's greater than the current max value, then I'm gonna assign to max value the current element, right? So, yeah. And then we are returning the main value. I don't know why it's giving me this.
Lydia, you didn't put the EF at the beginning of the function.
Oh, okay. Sorry. Max one. Oh. And then we can use this the same. Yeah, it's gonna give me the same. And in this case, it's a similar as this one, meaning that okay, if you can see, oh no, this not, it's gonna be of n directly. Because we are just integrating once in the array, and we are just evaluating if we had okay, if we have two nested loops, as I mentioned, it's gonna be quadratic. But if the loops are at the same level, so for example, if I have a 4 here element list and I want to do something else, then it's gonna be 2n, as I mentioned, n plus n equal to n, and then it's gonna be reduced to O of n, right? So yeah, just so you for taking into consideration, nested loops, it's gonna add up as many loops as you have, then it's gonna be quadratic, then it's gonna be to the power of 3, power 4, and so on. So avoid those. Okay. Okay, so yeah, we already completed the first two. And I want to go to VS Code to go to explain how we do it in VS Code. But if you have any questions before, please let me know, or if not, I can continue. Are we good? Or yeah, for space complexity, we're gonna see an example in which the space it's gonna be greater than of 1. But okay, so basically in here you need to see what variables are you using and what space they are taking, right? So it's similar as the input that you're receiving to go through the whole algorithm. So in here, for example, if I had a new list that I wanted to use for something, this is not gonna be constant, because if you see this mean value, it's just gonna be one value. This max value is just gonna be another one value. So it's gonna be constant. It could be 9, it could be 8, in this case, like -4 and 5. And they don't take any space because it's constant. It could be any number. But if we had a list in which we are inserting n values, so for example, if I have a list variable and it's a list, then this could increase to n in when it comes to space. So this, instead of being of 1, it's gonna be of n. But in this case, since we're having like only constant value, sorry, constant or variables that are just storing constants, then it's gonna be of 1. Since they are using the same list, then it's not necessarily the same list. This is just a value. So for example, this could be 1, but list, what is the first element of the list? The first element of the list is gonna be 1. So then min value is gonna be equal to 1, and max value is gonna be equal to 1 as well. So in here we are changing the values, the mean value values. Sorry for the redundancy. So but it's gonna be always constant. So in here it's gonna be -2, for example, or 3. So in the end, as you see, it's gonna be just constant values. It's not gonna be any other element that store more data. So it's not gonna be a list, for example, that store n elements. Yeah. So basically that's like the at least how I understand it, but yeah. Okay, that makes sense. Just the inter that exists. Yes. And Larry, sorry, made an explanation of why. Yeah, exactly. Yeah, he summarized everything. So of to n, it's gonna be linear because it's gonna be reduced. As we mentioned, we don't care about constants in the big O notation. And of n to the power of 2, it's gonna be when you have loop nested loops. Sorry. Okay, let's go to this one. Okay, so I have this rep, let's say. So the first thing, when you're using VS Code, you can initialize a repo. So the way that you do it is that you do git init, and that's gonna initialize, right, empty repository. So if you want to be like correct, what you're gonna do the first time that you are creating a repo, you are creating a git ignore file. So the git ignore, basically what it does, like you can add all the elements of all the files that you don't want to be tracked in Git. And you can also have readme And if you have seen maybe other repositories, basically, and this should be capitalized. Let me change. So if you maybe have seen other repositories, it's like to describe what the repository does. So yeah, this is like a good practice. Every time that you start a repository, initialize a repository, you include these two files. But yeah, that's like just to be correct.
Nydia, someone wants you to zoom in again.
Oh, okay.
Thank you.
No worries. Scanning this, I think. Okay, so we're gonna create a new file, and in here you can call it as you want. As convention, we usually have a main .py file. Okay, so in here, the first thing that you most likely are gonna see is that it's gonna be a main function. We're gonna have it empty for now, and we're gonna see this usually. And then this one is gonna call the main. Okay, this is for convention. It's to know where the script is being called. So for example, if you had any other like files, and maybe some of them are being called in the main script, let's say. So you just want to run this script or the main function on only if you are in this file. So this is for reference, basically, not for reference, like for common usage. But yeah, it's basically like that. So it's like to avoid running the main file unless it's within the main function. So yeah, it's something like that. Okay, so here we could have it the same. So this is gonna be the write up form to count the occurrences of a specific character in a string. Okay, so we're gonna have as well different approaches. So approach number one. So in here, what we could do is um call it like this, right? Find character in string. And when you're like naming your functions, try them to be as accurate of what they do. So it is easier to read for other people that maybe are like looking at your code or something. Okay, so we're gonna have a variable, and then we're gonna loop through the string. Okay, this is something interesting. The string behaves similar to a list, so you can also iterate through all the elements of the string, similar. So in here it's gonna be for character in string or for each character of the string. So basically, if the character is equal, or the character or the one that I am testing is equal to the character that I want to find, then we're gonna sum, right? And then we can return. Uh, and then we can return the number of this is count, right? And here, what we're gonna do is that we're gonna call the function, but we want the user to perhaps insert or input their own string and character. So what we could do is like use input. So here we could say enter string, and we leave the space here. So when it's inputted, it doesn't come like this, and you have like a space, enough space there. And we could also have the character, which gonna be enter and then we're gonna print the response of this. It's gonna be this. So we're gonna print whatever this function returns, and we're entering the string and the char as arguments, which are this basically. And then to run it, we just like go Python main py, and it's gonna say, so I can say my name is Nydia, and enter a char to find. It could be all the 8s. So it says the number of currents of 8 is 7. So yeah, this will be like the simpler way, let's say. But maybe this is well, the exercise said write the program to come to the currencies of a specific character, maybe not specific a string within a string. But yeah, for example, if in here I want to enter my whole name, like Nydia, is not gonna count because it's expecting a character, just one value, right? So it's not gonna, because in here we are iterating through all the elements of the list, then each element is a character, right? So it's not gonna find it, but we could use, so, oh well, and when it comes to time complexity here, since we are iterating through all the elements of the string, which is similar to a list, is the string can be of n characters. So it's gonna be of n. And space complexity, since we're not using any other like variables, it's gonna be of 1. Any variables that require more space, like another string, for example, or like a list or something. Okay, so then the next approach. Okay. So we can, so to avoid
Nydia, sorry to interrupt. Someone asked if you could explain the function of if name portion.
oh, this one.
Yeah, I think so.
Oh, okay. So basically, this is for convention. So what you want to, and not convention. Basically, this lets like when you are executing and you have like many other files running. So this said that only if you are within the file called main .py, then you execute this function, the main. So it's like, is for example, I have a number of any other functions here that maybe I call from another file. So if I had like a new file here and I call all the functions from here. So what it's saying is that if I am calling this main.py from another file, maybe you call it, I don't know, function.py or an example. It's not gonna run the main because it's not calling or it's not executing from the main. I don't know if I make myself clear, but yeah, basically it's like it's saying you can only run this main function only if you're executing from the main file. Yeah, exactly. Yeah, Larry explained it better than me. But yeah. Okay, so yeah, I hope that's clear. But yeah, it's basically, yeah, to prevent from executing from other files. Yeah. And yeah, he shared like uh a link. So yeah. Stream. So I'm calling it two here just to avoid so we could like change, because if I have it like with the same name, then it's gonna take just the last definition. So yeah, so just to avoid that. And we can like count using the method for string called count. So okay, so this is like the easiest way to do it. And this it uses like an existing method. And the good thing about this one is that this character doesn't necessarily need to be a character. It could be a substring from string, which was the scenario that I was mentioning. That, for example, in here, if I say my name, oh, and I didn't realize that I input my name is. My name is Nydia, and in here it's gonna count the occurrences of a substring. So it could be either a character or a substring of more characters. So, and if I say Nydia, then it's gonna say one. But if I use the other approach, it wouldn't consider the cases for substrings, for example. Yeah. Okay, so and the time complexity and space complexity is the same, since we are using a method for string, which is going over all the elements of the string, which behaves similar, which could be of any characters. And also space complexity, since we're not using any additional variables, then it's going to be of one. And then the last approach to how to solve this could be using regular expressions. So for this one to work, we need to import a library called import RE, which means regular expressions. So in here, we're gonna find the occurrences of a specific string using a method called find all. So so we could go like this, and it's gonna be find all, and basically in here you insert the character. Or
Nydia, can you show the top of your code again?
yes, import re. Okay. Okay, so we and the string, but this one, what it gives is a list with the times of, I mean, a list of that substring every time it was found. So this is the tricky part when it comes to space complexity, right? But yeah, maybe I can go over it after. I can explain. So since this is returning me a list, then in order to get the occurrences, I need to use a len, which is gonna count the elements of that specific list, like the length of that list. Sorry. And then I can use it as yeah, and it says 7. Okay, so this one is the one that is not behaving the best, and this is an example of space complexity of n. So we have time complexity. In this case, we have of n. But in the case of space complexity, different than the existing ones, we have of and as well. This is why the way that this specific method works, as I mentioned, it's gonna create a list with the substring repeated every time it finds it. So for example, in the case of A, which was the one that we found, it's gonna be like this. A, and so on, like every time it found the A. So it's gonna be this. So this is a list, and a list could be of n elements. So the space is gonna be, or the complexity, the space complexity is gonna be of n, because we don't know how many times a specific character can be found. So this could be 7 times, this could be 10 times, this could be a million times. So that's why we are having in this specific case a of n. And then we're using the length to get the length of the list, basically. So yeah, basically, yeah, I think those are the three approaches. And I try to find different approaches for the three problems. But yeah, I mean, you could do it as simpler as you did maybe, or you could do it as advanced as you would like to. Just take into consideration perhaps time complexity and space complexity, to avoid performance issues. So because okay, this is like one function that's of n, but what happens if we have a lot of files and maybe we have like a nested loop there? So, and if many people are consuming those files, then it's gonna increase like the time that is taken to run. So yeah, just take into consideration for when you're trying to write like a function or whatever.